Hey friends, welcome back. So now we will see another exploratory data analysis on data pre-processing with missing values and outliers. So what is the agenda or the content is we will be introducing ourselves with ways to detecting missing values, right? Standard and non-standard missing values, basic impute method for replacing missing values, identifying and removing duplicates from your data, right? We will see outlier detection visually by z-score, right? And we will also replace outliers by median. We will also check that how we can do outlier detection using IQR, right? We will also replace outliers by whiskers, and we will also remove or modify incorrect or unwanted observations. So let's get started now. First, dealing with missing values. So here what we're going to discuss is how we can find or deal with our missing values in our data set, right? So let's import the necessary libraries: pandas, numpy, again seaborn, and matplotlib for visualization. Now reading the data. So what we do is we simply read the data by using read CSV. Again, we'll also provide the same data set in the below description box as well. So this is, you can see the data looks like. So we will have to start observing things from the very first step, right? So here you can see that if we observe the data, we can recognize the missing values, like there are none, or the values, we can say the garbage value, they are not useful with our analysis, right? So second thing is the data of type of missing value don't necessarily have to be np.none, right? So they could be like anything if there is no useful information, and based on the context we often decide what should be a missing value, and we qualifies as valid data, right? So let's deal with the duplicates with our data. So to check the duplicacy in our data set, we just use the duplicated function. So that will return the number of duplicates values, it return basically true or false, whether the value are duplicated or not. But here we just want duplicate. So whenever we get true values here, so we will sum those value and return that. So here we have 13 duplicates value in our data, right? And here we can see that there is 13, as I said, and we want to remove this duplicate rows because we don't need them. So what I'll do is I'll tell that okay, just drop duplicates in our data set, right? So just calling the drop duplicates function again. So now if I again check the duplicate, so here you can see that this time we get 0 duplicates in our data. All right, let's deal with the missing values with our data. So again, how we can get those missing values? As I said that we have normally is null function, right, that recognize the missing value. So here in our data frame we can get that values, right? Well, in values we are getting number of data, and in missing we are getting that if it is null, then return true, else return false. So here you can see that with these values, these are the missing numbers. So there is no missing values, but there is missing values, right? So that is true. Now similarly we will check with non-standard missing values. So again you can see that we will get the same. If there is none, that will return true whether it is missing values or not. But here you can see that we have non-standard value, like you can see that this is also not useful with our case, this is also not useful in our case, right? So in such case what it will do that, because is null only check whether there is null or not, but these are also not useful information for us, right? So we will also have to deal with them. Next thing is we can have unexpected missing values. How they could be unexpected missing value? Here you can see that there could be a column with useful information, right? So what if we have information like this, like in state we don't know what n is, we don't know what y is, right? So because that we can say that how these values are initiating, because y is two place, so they are referring to different column, right? So how we can do that? So that is also a type of unexpected missing values. Now what we'll do is we will get the number of missing values, only one recognized as missing values, right? And in each attribute, so what we'll do is we will get that is null dot sum, and we are checking that number of missing values. So here you can see that if there is null found, then only it will return the sum of those missing values, right? We have another function that is any with our missing value. So what any function will return that if there are any of the value in the data frame is missing, then only it will return. Let's say there are no missing value, or we can say no null values in our data set, then it will simply return false. Next thing is the total number of missing values. Again, what we do is we will sum the missing values. So first we will sum those missing values, again sum to return the overall sum for those missing values. So basically that recognize missing value in entire data frame, right? Now replacing missing values. So here the journey starts since we have seen that how what kind of missing values we can have, what kind of data that is not useful in our case. So now how we can replace them? So there are many values in which missing values cannot be replaced by different values, which often called as imputing missing values, right? So it depends on our data and the problem that we are solving. So let's try to impute the missing values. So first, again, what we'll do is we will replace the none with the custom value. So let's say in this particular column we are filling the NA values. So the NA values this time will be filled by 1 2 3 4, and in place is true, that will replace permanently, right? We also have other method to fill those NA, like we can also replace none values with the mean of the column, right? So again, in this particular column we can say that fill NA with the mean of this particular number. We can also fill them with median by just calculating median of these values. So here if we get the data, right, and you can see that if there would be any null value, that have been replaced with 1 2 3 4 1 2 3 4 5, right? 1 2 3 4 5. Now how to get the location based replacement? So if we want to replace any particular value, so first we will use the log method. In the log we will pass the index and the column, right? And in that particular we just want to perform store this new value that we are giving 1 2 3 4. So replace a value at a specific location. So here you can see that since we are passing only 1 2 3 4, but it is taking it as 1 2 3 4.0, just because the number, the data type that matters with the number. So if we can see that basically happens just with the data type. Now we drop the row with missing value. So again we drop NA, right, and in place true. So what it will do is it will drop all the row that have at least one missing values. So here with number, that is 0 missing values, city 0, and so on so forth, we have 0 missing values. Let's see our data this time. So now getting rid of row with missing value is the easiest way of dealing with their presence, right? But the downside is that we lose valid data from other column which do not have missing value for the particular row. Exactly. So in that case we deal with incorrect or unwanted observation. So let's say we are accessing the tail this time. So here you can see that some incorrect and corrupted values, so like this, right, like this. Okay, so you need to look for such values manually sometime, and you can also use summary stats or plot to find such values. So these value can be modified based on the problem you are trying to solve and what is required for your case. So here we can say that with this particular value that can be replaced by null or most common color value, that is at the rate. So that is also like a null value which can be imputed based on the method shown above, right? So we try to modifying these incorrect values based on this case. So Let's start with outlier. Now, how we can deal with that in the part given this, right? We will discuss outlier in a data set. So let's discuss the data set first. So we'll be using Boston house pricing data set, which is included in this sklearn dataset API, right? So we will load the dataset and separate out the feature and target. So let's import the sklearn dataset with load Boston, right? Here you can see that we will get the Boston dataset. X we will get the data, and Y we will get the target of that Boston, right? And column will be our features name. So if we get the that in a data frame, so we are converting in Boston DF, right? We will get the columns as dot column, and we are getting the head for that. So here these are the column that we got, and this is the column. Now we will discover the outlier with visualization tool. So for the outlier, again the box plot comes in our mind. So we will import Seaborn for advanced visualization, and we are plotting a box plot for this DIS column, this particular column, right? So here you can see that we got the box plot. Now in this plot, between 10 to 12, right, you can see 10 to 12, these are nothing but the outlier, as there are no included any box of the observation, or we can say where near the quartile will be there. So this is what the outlier are. If we try to get that in a scatter plot, so you can see that again we will access the scatter plot for non-retailer business, acres per town, or full value property tax rate for per $10,000, right? So this is looking at the plot above, we can see most of data point are laying on the bottom left side, right? But there are points which are far from the population, like top right corner, those are potential outliers. So you can see that most of the value are here, but these are nothing but the outliers which are far from with the potential outliers. Now we will discover outliers with statistical rules. So first thing we have is z-score. Again, we will import the stats from our SciPy. So in that stat, we will get the z-score, right? Getting the z-score of every value with respect to their column. So this is nothing but z-score, and it is sometimes very difficult to say that which data point is outlier in this, right? So let's try to define a threshold for that to identify an outlier. So we are defining the threshold here, and now we are checking if the z, that is our z score, is greater than threshold. So the first array that contain the list of row number, and second array respective column numbers, right? Which means z55 1, okay, have a z score higher than 3. All right. So here you can see that again we printed that this one. So this will definitely return the value of z55 1, z55th row and first column, right? So this way we will get the 55th record on column zn as an outlier. Now again, to get the IQR, we will get the quantile for first quantile, then we are getting third quantile, and this is nothing but the interquantile. So this will return the IQR for every attributes in the data frame. So here you can see that again we are checking with the condition that where Boston DF is less than DF minus 1.5 into IQR, or Boston DF is greater than Q3 plus 1.5 into IQR. So return all these values. Now let's work with the outlier, like correcting or removing them. So with this particular data frame, we are only selecting those rows without a single outliers, right? So this is the row that we will get there without any single outliers, right? And let's make a copy in df2. Then here what we will do is we will replace all outlier with median values. This will create new some outliers, like we will just ignore them in our case. So here we are iterating using two variables, right? That is for I and j. All right. And I is basically for row here and j is for column. Then here what we are doing is we are replacing I and jth element with the median of j, that is nothing but the corresponding column, right? And here what we will do is we are getting new outlier detected after imputing the original outlier. So here it will return me the new z score. So now how can we get the IQR score? Just like Z score, we can use previously calculated IQR score to filter out the outliers by keeping only valid values, right? So here we will do nothing but the row, we will get the row without outliers. So that will return the particular row here. Now again we are making a copy in EDA-4 and replacing every outlier on the lower side of the lower whiskers, right? So this will nothing but replace every outlier with lower side, and next thing what we will do is we will replace every outlier on the upper side of the upper whisker. So that is for lower whisker, that is for upper whisker, and at the last we will get the final rows for those whiskers, right? So yeah, this is all about it. You can also play with it, do some mindful or logical coding according to you and your analysis. Thanks.